Look inside the flap of an old-style paper milk carton, the kind with a folded gable top that you pull apart and fold back to make a spout. And for most of the 20th century, you would find a company name printed in small type there that almost nobody ever noticed or bothered to ask about. That company built the machines that folded, filled, and sealed billions of those cartons. It also built the boring machines that bored the cylinders in millions of American automobile engines on Detroit assembly lines, and jet engine components flown by the United States military, and grinding equipment precise enough to finish gauge blocks used to calibrate other machines to millionths of an inch. It is entirely possible you have never heard of it, despite the fact that its products, or the descendants of its products, have passed through your hands more times than almost any single machine tool company in this entire history of forgotten tool makers. By 2006, the company had been gone from the machine tool trade for years in every meaningful sense. Its most famous products sold off to a Norwegian packaging firm 2 decades earlier. Its European machine tool operations spun into a completely separate corporate lineage that eventually ended up owned by a Japanese company, and its American parent finally laying off its last employees after 87 years in business. This is the story of Excello Corporation, a Detroit tool and die shop that ended up touching more corners of ordinary American life than almost any company in this history, and then quietly came apart into 3 unrelated pieces that most people using its products today have no idea ever shared a single name. The company began in 1919 when a group of tool and die makers in Highland Park, Michigan, all of them former employees of the Ford Motor Company, pooled their skills and their savings to found the Excello Tool and Manufacturing Company. Their original shop sat just a few blocks from the Highland Park Ford plant, the factory where Henry Ford had installed the world's first moving automobile assembly line only a few years earlier, and the men who started Excello had almost certainly worked on or around that very line before striking out on their own, carrying with them the exacting standards for interchangeable, tightly toleranced parts that Ford's own moving line production system had demanded of everyone who ever touched it. Founding a tool and die shop within walking distance of the plant that had just reinvented American manufacturing was not an accident. It was where the skilled labor pool, the customer base, and the accumulated know-how all happened to be concentrated at that exact moment in industrial history. And dozens of similar small shops sprang up around Highland Park and the wider Detroit area in the same few years. Most of them founded by men who had learned their trade the same way, on Ford's own factory floor, before deciding they could do better, running a shop of their own. Newton Woodworth, known to the trade as Woody, served as the new company's first president and general manager. In its earliest years, the firm found an unexpected niche. Roughly 60% of its business came from manufacturing precision parts and fixtures for the still young aviation industry, an industry that in the early 1920s barely resembled the one that would emerge a generation later, but was already demanding tolerances well beyond what most general machine shops of the era could reliably hold. Work demanding enough that the company changed its name in 1927 to the Excello Aircraft and Tool Corporation to reflect where its real expertise lay. Around this time, it also began building grinding machines, including some sold under the Carbaloy brand for the Carbaloy Company itself, and air-driven grinding spindles, laying the groundwork for what would become the company's core machine tool business for decades to come. In 1937, Woodworth left the company he had helped found, and the firm reorganized under a simpler, more general name, Excello Corporation, chosen deliberately to reflect a product line that had grown well beyond aircraft parts and now included high-precision thread grinders, boring machines, facing machines, and lapping machines. A broader identity that the old aircraft-specific name no longer fit. It is worth pausing on what a lapping machine actually does, because it represents one of the genuinely finest levels of precision available in mechanical manufacturing, and because it is exactly the kind of unglamorous, invisible capability that would come to define almost everything this company touched. Grinding, using a rotating abrasive wheel, can bring a metal surface to a very fine finish and a tight dimensional tolerance. But there is a level of flatness and surface perfection beyond what grinding alone reliably achieves, especially on the kind of reference surfaces where even a few millionths of an inch of error compounds into real measurement error downstream. Lapping works by charging a soft, flat plate, called a lap, with an extremely fine abrasive compound suspended in oil or another carrier fluid, and then running the workpiece against that charged surface under light, controlled pressure, slowly wearing away microscopic high points until the surface approaches true flatness, sometimes to within millionths of an inch. It is a slow, almost gentle process compared to grinding, closer in spirit to hand polishing a lens than to cutting metal, but it is exactly the technique needed to finish the reference surfaces of precision gauge blocks, valve seats, and other components where even a grinding wheel's fine finish is not quite good enough. XLO's lapping machines put that capability into the hands of ordinary manufacturers rather than specialized instrument makers alone. A democratization of precision, not unlike what other companies in this history achieved with the vernier caliper or the micrometer, just accomplished with an abrasive plate instead of a measuring scale. The strangest and, in hindsight, most consequential turn in the company's early history had nothing to do with either aircraft or machine tools. In 1915, a package designer named John R. Van Wormer had patented a folded paperboard container for milk, built so that when its top was opened, it formed its own pour spout, a design meant to replace the returnable glass bottle that had dominated dairy delivery for generations. The glass bottle industry did not surrender its share of that market willingly, and Van Wormer's design struggled for years to gain traction against an entrenched, well-capitalized incumbent that dairies already understood, trusted, and had built their entire delivery infrastructure around. Van Wormer sold the rights to his design, which he called Pure-Pak, to the American Paper Company in 1928, but that company ran into an obvious problem. It had no machine capable of folding, filling, and sealing the cartons fast enough to matter at commercial scale, and a clever container design is worthless to a dairy processor if nobody can actually produce it in the volumes a modern bottling plant requires. It contracted the job out to XLO, a Detroit machine tool builder that, on paper, had absolutely nothing to do with the dairy business, a decision that, in retrospect, looks like one of the more unusual and consequential engineering commissions in 20th century packaging history. The machine XLO's engineers came up with took a flat, die-cut paperboard blank, folded it along pre-scored lines into a rectangular tube, sealed the side seam, folded and heat-sealed the bottom shut to form a leak-proof base, ran the open-top carton beneath a filling head to dispense a precise volume of milk, and then folded and sealed the gable-shaped top, all in a single continuous automated sequence that no human hand needed to touch between the flat blank going in and the finished, filled carton coming out the other end. Mass production began in 1937, and the very first XLO Pure-Pak machines went into service at a Borden dairy plant in Ohio, where they turned out 42 million finished cartons in that first year alone, an almost unbelievable volume for a packaging format that had barely existed as a commercial product a decade earlier, and had spent most of that decade struggling for acceptance. The early cartons were simply folded and stapled shut, a design good enough to hold milk, but not particularly convenient to open. It was not until the early to mid-1950s that the company introduced the familiar pitcher pour design, glued at the top and folded back and forward to reveal a built-in spout. The version that would become instantly recognizable to anyone who grew up drinking milk from a paper carton for the rest of the 20th century. And it was that pitcher-pour redesign that finally attracted serious international attention to the format. In 1956, a quintjury Norwegian paper engineer secured a license to bring Pure-Pak to the European market, founding a company whose name was simply a shortened version of European License Organization, Elopak. While that packaging side of the business quietly grew into a global standard, almost nobody associated with a machine tool company. Excello kept building its core aerospace and precision equipment lines through the years leading up to the Second World War. In 1948, the company acquired Robbins Engineering of Detroit, a firm specializing in jet engine rotors and related components, cementing its position inside the newly emerging jet age, just as piston aircraft engines were giving way to turbines across both civilian and military aviation, a transition that was reshaping the entire aerospace supply chain and rewarding companies that could pivot their precision manufacturing capability toward the much tighter tolerances turbine components demanded, and giving Excello a genuine foothold in a technology that was about to reshape military and commercial aviation for the rest of the century. During the war itself, Excello had already been part of what the country called the arsenal of democracy, the vast, decentralized network of ordinary manufacturers that Detroit and the rest of industrial America converted almost overnight into weapons production, manufacturing nozzle plates for rockets, aircraft engine parts, and the boring machines, thread grinding machines, and center lapping machines other war contractors needed to build their own equipment to the tolerances modern weapons demanded. A company that had started out grinding aircraft fixtures and folding milk cartons found itself, within 2 decades, equally comfortable supplying rocket components and the precision tools other factories needed to arm themselves. The post-war decades brought the company's other major technical identity into focus: the transfer machine. As American automakers scaled up passenger car production through the 1950s to meet a booming post-war consumer economy, they needed a fundamentally different kind of equipment than a general-purpose machine tool sitting on an ordinary shop floor. An engine block is a large, heavy, complicated iron casting that needs dozens of separate operations performed on it in a specific sequence: boring cylinder bores, machining crankshaft and camshaft bearing surfaces, drilling bolt holes, facing mating surfaces, and running that same casting through dozens of separate general-purpose machines, one operator loading and unloading it by hand at each stop, was far too slow and far too labor-intensive for the volumes Detroit needed to hit at Cold War-era production scale. A transfer machine solved that by chaining a series of dedicated machining stations together with an automated transport system, so that a raw engine block casting entered at one end was automatically clamped, positioned, and machined by a fixed sequence of tools at each station in turn, then automatically transferred to the next station down the line without a human hand moving it in between, and emerged from the far end as a fully machined block ready for assembly, often only minutes after the raw casting had entered. Each individual station in a transfer line was built to do exactly one job, and only that job, for years on end, which made the whole system extraordinarily fast and consistent for high-volume production, at the cost of being essentially impossible to reconfigure for a different engine design, without rebuilding large portions of the line, a trade-off automakers were happy to accept as long as a given engine stayed in production for years. Excello became one of the major American builders of exactly this kind of equipment, and its block and connecting rod boring machines turn up by name in the documented equipment lists of real Detroit engine plants from this era, including the Chrysler Corporation's Mound Road facility in Detroit, where Excello boring machines, semi-finished cylinder bores, and machined camshaft and crankshaft bearing surfaces on the production line built for Plymouth's new A-block engine in the mid-1950s, working alongside equipment from Barnes Drill, Blanchard, Cincinnati, and a long list of other specialized machine builders, each one an invisible name. Most drivers of those cars would never learn. Buried inside a factory, most of them would never see. By the 1950s, XLO had become, by most industry accounts, a genuinely leading machine tool builder, credited with pioneering and perfecting a range of machining processes well beyond its original grinding and lapping business. It expanded aggressively overseas to serve that growing automotive customer base outside the United States as well, reasoning correctly that European and eventually Asian automakers would need the same kind of high-volume transfer machinery Detroit had already come to depend on, and that shipping every machine across the Atlantic from Michigan would never be competitive against a builder with local manufacturing. The company acquired a machine tool plant in Göppingen in southern Germany in 1958 and built new manufacturing facilities nearby at Eislingen an der Fils to serve the European automotive industry directly, rather than exporting everything from Michigan, an operation that would go on to build an international reputation of its own for the quality and productivity of its standard machine tools, transfer lines, and special-purpose machines. That same general period saw the company establish an Indian operation as well, founded in Bombay in March 1958 as Messrs. Amerind Engineering Company with American technical and equity support, manufacturing propeller shafts, machine tools, and steering gear assemblies for the Indian market, before eventually being renamed XLO India Limited, and in 1978 becoming fully Indian-owned and independent of the American parent under the name XLO India Limited, an early and fairly clean example of a foreign subsidiary, simply buying itself out entirely, rather than being sold or spun off by its parent. By the mid-1960s, the American parent company had relocated its headquarters to Troy, Michigan, a Detroit suburb, reflecting just how thoroughly the company's identity had shifted from its original Highland Park tool and die roots toward a genuinely international, diversified machinery and aerospace components business, one whose products range from jet engine parts down to the humble folded milk carton with almost nothing recognizably in common between them except the same company name stamped somewhere on the equipment that made them. That diversification, which had kept the company resilient for decades and given it a genuinely unusual footprint across aerospace, automotive tooling, and consumer packaging all at once, also made it an unusually attractive target once the wave of corporate takeovers that defined American business in the 1980s came looking for undervalued conglomerates with valuable pieces scattered across multiple industries. The logic driving that decade's takeover boom was straightforward and, for a company like XLO, dangerous. If the sum of a diversified company's individual businesses was worth more sold off separately than the whole company was worth trading as a single stock, then buying the whole thing and breaking it apart could be enormously profitable for the acquirer, regardless of how well any individual piece of the business was actually performing on its own, and regardless of what happened to the employees, the plants, or the century-old identity the company had built up along the way. In the summer of 1986, Textron Incorporated, an existing conglomerate with deep roots in the defense and aerospace industry, launched a tender offer for XLO, an offer that press coverage at the time pegged at roughly $966 million, before Textron indicated it might raise the bid further. A public back and forth that played out in the pages of the New York Times and the Los Angeles Times over the following weeks as the two sides negotiated. By the time the deal closed later that year, Textron had agreed to pay $77.50 per share in cash, a total transaction value of approximately $1.1 billion, worth something on the order of $3 billion in today's money, making XLO a wholly owned Textron subsidiary and ending 67 years of independent existence for a company that had started as a handful of Ford toolmakers pooling their savings in a Highland Park storefront. What happened next revealed exactly what Textron had actually been buying. Not a single coherent machine tool business, but a collection of valuable, largely unrelated pieces that made more sense sold off separately than kept together under one roof. Within a single year of the takeover, in 1987, Textron's XLO sold the worldwide Pure-Pak license outright to Elopak, the Norwegian company that had been operating as XLO's European licensee for the milk carton business since the 1950s, handing over full ownership of a packaging technology that by then was filling billions of cartons a year across dozens of countries, and had grown into a business considerably larger, in its own quiet way, than most of XLO's machine tool operations. That same year, 1987, the company's German machine tool operations became an independent entity, under German ownership as well, spun free of the American parent entirely, with a new sales and service company set up in Michigan to keep servicing the American market from the far side of that separation, eventually forming its own holding company and listing shares on the German stock market by 1989. Two of the company's most historically significant product lines, the accidental packaging empire built on top of a milk carton. Nobody at the original firm had asked to build, and the entire European machine tool business were carved away from the parent within 12 months of Textron taking control, leaving the remaining American operations to carry on as a comparatively narrower aerospace and machine tool subsidiary, still profitable, still respected within the trade, but no longer the same sprawling, internationally diversified company it had been just a few years earlier. That German lineage kept moving through corporate hands on its own separate trajectory afterward, becoming part of the IWKA Corporation's machine tool group out of Karlsruhe, alongside other historic European builders like Boehringer of Göppingen and the Frohlich Group, then merging into a company called the MAG Group in 2005, and eventually landing inside Japan's OSG Corporation, a cutting tool manufacturer, which still operates under the name OSGXLO-GmbH, and still manufactures precision spline rolling and cold forming machinery in Germany today, a direct lineage from that 1919 Highland Park tool shop that has now spent longer under foreign ownership, structurally disconnected from its American origin, than it ever spent as part of the original company at all. The American parent, meanwhile, carried on for another 2 decades as a Textron subsidiary, still headquartered around the Detroit area, still building precision machine tools and aerospace components for a defense and automotive customer base that had never particularly cared whether the company also happened to own the rights to a milk carton design, even opening a new special machine tool assembly plant in Sterling Heights, Michigan in 1992, a sign that Textron still saw enough value in the remaining American machine tool business to keep investing in new capacity for it, rather than simply running the operation down. But the identity that had once spanned milk cartons, jet engines, and automobile transfer lines under one recognizable name had already been permanently split apart years earlier, and the American operation that remained was, by any meaningful measure, no longer the same company that had built that reputation in the first place. Just the piece Textron had decided to keep running rather than sell. A narrower, and in some ways, more ordinary machine tool and aerospace supplier trading, under a name that used to mean something considerably stranger and more far-reaching. On April 28, 2006, XLO began laying off its remaining employees, quietly closing out 87 years of continuous operation without the kind of dramatic bankruptcy filing or public collapse that ended so many of its contemporaries in this history. There was, by that point, simply nothing left to collapse dramatically. The name had already been scattered across 3 continents and 3 unrelated industries for nearly 2 decades. And what finally shut its doors in 2006 was, in a real sense, only the last and least surprising of the pieces to go. There is something almost perfectly fitting about how thoroughly ex-Cello's legacy disappeared into the ordinary background of daily life, rather than into any single dramatic downfall. Nobody watching a documentary about the American automobile industry expects to hear the name of the company that bored the cylinders in a 1955 Plymouth engine block. Nobody pouring milk from a paper carton, gable top folded back to reveal its built-in spout, has any reason to know that the machine which made that carton traces its lineage to a group of laid-off Ford toolmakers in Highland Park, Michigan in 1919. Nobody flying on a commercial jet has any reason to wonder whether some small rotating component inside the engine beneath their seat descends from a Detroit acquisition made in 1948. That is, in the end, the particular kind of legacy a company built on precision measurement and invisible manufacturing infrastructure tends to leave behind. Not a monument, not a household name, but a diffuse, largely unrecognized presence spread across 100 different products that people encounter every day without a second thought. The company that quietly built the machines behind some of the most ordinary objects in 20th century American life ended up as ordinary and unremembered as the objects themselves. Its three surviving lineages: a Norwegian packaging giant, now counted among the largest carton manufacturers on Earth; a Japanese-owned German machine tool maker, still cutting precision splines under a name it inherited rather than built; and the empty space in suburban Detroit where a Michigan company used to be, carrying almost nothing forward except the products themselves, still doing exactly what they were built to do, for people who will never know or need to know where they actually came from.